Hi everyone, welcome back to video series on Windows Server 2016 Ipconfig flushdns. Just one final note to finish out this section. I have been saying things like now when I do this or immediately following this change, and if you're creating some of your own records, you may have noticed that it sometimes takes a while for your client computers to recognize these new records. This is normal behavior, and the time that it takes before your change rolls around to the whole network will depend entirely on how large your network is and how Active Directory replication is configured. When you create a new DNS record on one domain controller, your new record needs to replicate itself around to all of the other DCs in your network. This process alone can take up a couple of hours if AD is not configured for faster replication. Typically, it takes only a few minutes, and then once the new record exists on all your DC servers, your clients may still take a little bit of time to utilize the new record. Because client computers in a domain network hold onto cache of DNS data, this way they don't have to reach out to the DNS server for every single name resolution request. They can more quickly refer to their local cache in order to see what the information was from the last time they checked in with the DNS server. If you are trying to immediately test out a new DNS record that you just created and it's not working, you may want to try to run the command ipconfig/flushdns on your client computer. This forces the client to dump its locally cached copies of DNS resolver records and go grab new information that is current from the DNS server. After flushing your cache, the record will more than likely start working properly. DHCP versus static addressing. IP addresses on your network are sort of like home addresses on your street. When you want to send a package to someone, you write their address on the front of the package and set it in the mailbox. In the same way, when your computer wants to send data to a server or another device on a network, each of those devices has an IP address which is used for the delivery of those packets. We know that DNS is responsible for telling the machines which name resolves to which IP addresses, but how do those IP addresses get put into place on the servers and computers in the first place? Static addressing is simply the process of configuring IP addresses on your system manually using your own hands as the configuration tool in order to plug all of your IP address information into the NIC settings on that device. While this is a quick and easy way to get network traffic flowing between a few endpoints, by giving them each an IP address, it is not scalable. We do often statically address our servers as a way of making sure that those IP addresses are not subject to change. But what about on the client and device side? Even in a small company with 10 employees, each person may have a laptop, may have a desktop and a laptop. There are likely going to be print servers on the network also needing IP addresses. And you may have a wireless network where employees or even guests can connect with phones and other devices in order to gain internet access. Are you going to assign IP addresses by hand to all of these devices? Certainly not. Our answer to this problem is the Dynamic Host Configuration Protocol, DHCP. This is a protocol which is designed to solve our exact problem by providing the ability for machines and devices on your network to automatically obtain IP address information. Almost any user on any device in the entire world uses DHCP, every day without even realizing it. When you connect your laptop or smartphone to a Wi-Fi router to gain internet access, a DHCP server has given you the ability to route traffic on that Wi-Fi network by assigning you IP addressing information. Often in the case of a public Wi-Fi, DHCP server is actually running on the router itself. But in our business where Windows Server rules the data center, our DHCP services are most often hosted on one or more servers across the network. The DHCP scope in the new Windows Server 2016 lab environment I have been building so far, I have been statically assigning IP addresses to all of the servers that are being built. This is starting to get old and hard to keep track of. When the first domain controller was configured, I actually installed the DHCP role onto it, but I haven't told it to start doing anything yet. What does a DHCP server need in order to start handing out IP addresses? It needs to know what IP addresses, subnet mask, default gateway, and DNS server addresses are within your network so that it can package that up and start handing the information out to the computers who request it. This package of information inside the DHCP server is called a DHCP scope. Once we define our scope, the DHCP server will start handling out IP addresses from that scope to our new servers and computers which do not already have static addresses defined. Once again, we need to launch a management tool on our Windows Server 2016. And once again, the easiest way to launch that is by using the Tools menu inside the Server Manager. Go ahead and launch the DHCP Scope console. Inside, you will see the name of your server where DHCP is running. Expand that, and you have options for both IPv4 and IPv6. Yes, this means that you can use this DHCP server to hand out both IPv4 addresses as well as IPv6 addresses for those of you who are testing out IPv6 or have plans to do so in the future. For now, we are sticking with good old IPv4. And so I can right click on IPv4 and choose to create a new scope. This launches a new scope wizard, which walks you through the few pieces of information that DHCP needs in order to create a scope that is ready to start handing out IP addresses inside your network. As soon as you finish creating your scope, it is immediately active, and any computer in your network whose NIC is configured to grab an IP address automatically from a DHCP server will start doing so against this new DHCP server. Now that our new scope has been created, you can expand this scope inside the DHCP console and see some additional information about the scope. By clicking on the address leases folder, you can see all of the DHCP addresses that have been handed out by this DHCP server. As you can see in the following screenshot, I have a Windows 10 client computer on the network, which does not have a static IP address, and so it grabbed a DHCP address from my DHCP server. It has been given that first IP address that I defined in my scope 10.0.0.100. The next machine which reaches in to grab an IP address from this DHCP server will receive 10.0.0.101 and so on from there. DHCP reservations. Assigning IP addresses from a big pool of available ones is great, but these address leases are subject to expiry and change. This means that a computer who has 10.0.0.100 today might receive 10.0.0.125 tomorrow. Typically, this is fine from a desktop computer perspective, as they don't generally care what IP address they have. But what if you have a more permanent fixture in your network, like a Windows server, but you don't want to have to deal with the statically addressing this server? This is where DHCP reservations come into play. A reservation is the act of taking a single IP address within your DHCP scope and reserving it to a particular device. This device will receive the same IP address every time it connects through the DHCP server, and this particular IP address will not be handed out to any other device on your network. By using reservations inside DHCP, you can allow the DHCP server to handle the assigning of IP addresses even to your permanent servers, so that you do not have to manually configure the NICs of those servers, yet still maintaining permanent IP addresses on those machines. You can see the folder called reservations in the DHCP console. Currently, there is nothing listed here, but by right-clicking on reservations and choosing new reservation, we will create one for ourselves. Let's work once again with that Web1 server. Right now, I have a static IP address assigned to Web1, but I will instead create a reservation for it on IP address 10.0.0.150. Most of the information on the screen makes sense. A quick description of the server name and the IP address itself. But how did I come up with that MAC address? A MAC address is a network card's physical address on the network. When your networking equipment tries to send information to a certain IP address, or in the case when the DHCP server needs to hand a certain IP address to a particular NIC on a server, it needs a physical identifier for that network card. So this MAC address is something that is unique to the NIC on my Web1 server. By logging into my Web1 server, I can run an ipconfig /all and see the MAC address listed for my NIC right in that output. That is where I got this information. This is how DHCP decides when to invoke our reservations. If a network interface asks it for a DHCP address and that device's MAC address is listed here in the reservations, then the DHCP server will hand that reserved address back to the device rather than the one from the general pool. Now that our DHCP reservation has been created, I will head into the NIC settings on my WETB1 server and get rid of all the static IP addressing information by choosing the default option, obtain an IP address automatically. After doing that, Web1 will reach over to DHCP and ask for an IP address. And you can see that I have now been assigned a reserved address of 10.0.0.150. This will always be the IP address of the Web1 server from this point forward, unless I change my DHCP reservation or somehow change the MAC address of Web1. This could possibly happen if I were to install a new NIC into Web1. Okay, so I'm going to leave this video here for today. If you like listening, please consider like, sharing, and subscribing. Thank you.